This other limit theorem has some similarity with the limit theorem dealing with rational functions, because a quotient is a division, all right? In this case, you have two different functions, one divide the other. So, suppose you have a function and you have its limit. Say the limit as x tends to a number c of f of x is equal to an answer L. Now, you also have another function. The limit as x also tends to c of a different function g of x, and say that one is equal to 0. Now, L here is not equal to 0. Alright? Now, what you find is the limit as x tends to the number c of f of x divided by g of x will not exist. Why? Because you're dividing by 0. You're not supposed to do that, right? Even if f of x were 0, if the limit was 0, you still have 0 over 0. You can't do that. Now let's look at a few examples. Suppose you have the limit as x minus 1 divided by x squared plus 1, and the limit is as x tends towards 1. Let me divide the board. As x goes towards 1, what happens in this case? As x tends to 1, then f of 1 would be equal to 1 minus 1 divided by 1 squared minus 1, no, plus 1 equals 1 minus 1 is 0. 1 squared is 1. 1 plus 1 is 2. Okay, so the limit is 2. Good. The limit of this is 2. Let's look at another example. Here you have the limit as x tends to 1 of x minus 1 divided by x squared minus 1. Substituting the values at the top, 1 minus 1 divided by 1 squared minus 1 will give you 0 divided by 1 squared is 1, 1 minus 1 is 0. It seems as if it doesn't exist. But the next thing we consider is, how can we divide by an x or an x squared, or multiply by an x or an x squared, or factorize anything here? So we examine the function and see, and by the way, I had left out my bracket. The limit applies to both, so I put it in bracket. Can we factorize this? Yes, this is the difference of 2 squares. So we can say that this function is the limit as x tends to 1 of, factorizing it now, x minus 1 divided by x plus 1, x minus 1. What did I write? X minus 1. What you have here is that x minus 1 cancel x minus 1. So what you have is 1 divided by x plus 1. Now let's see what happens. The limit as x tends to 1 of this is 1 divided by 1 plus 1, which is 1 divided by 2. Okay, good. So we do have a limit there. Alright? We do have a limit. Let's look at one more example. Oh, I'm skimming off part of my line. I don't want to touch the line, the dividing line. Okay, good. Let's look at another example here. We want to find the limit as x tends to 1 of x plus 1 divided by x squared minus 1. Okay, what will that amount to? If we plug the 1 directly here, you will have 1 plus 1 divided by x squared minus 1 is 1 squared minus 1, which is 2 divided by 1 squared is 1, 1 minus 1 is 0. Can't work. So we see if we can change up this function in any way. I see that here the x squared minus 1 can be factorized with a difference of 2 squares. So you have x plus 1 divided by x plus 1, x minus 1. Now, x plus 1 cancels x plus 1. So what we have is 1 over x minus 1. Now, what happens as x tends to 1? 1 divided by x becomes 1 now. 1 minus 1 equals 0. Well, in this case, equal 1 over 0. In this case, it is undefined. This cannot work. So, in this case, the limit does not exist. Alright? We got a number over 0 and we tried to escape from it by changing up the function, and we still get a number over 0. So the limit does not exist. Now, let us look at the graph of the second to last function and the last function as well. Let's erase this graph and this old graph here. Now, the second to last function we had was x minus 1 over x squared plus 1. So, x minus 1 divided by, bracket, x to the power of 2 plus 1. So, x squared plus 1. No, minus 1. It was minus 1. Okay. Illegal function. Let's see what happens here. X minus 1 over x squared minus 1. So this is x minus 1 divided by x squared. Oh, minus. I pressed x squared equals 1. It should be x squared minus 1. Okay. Let me make this thicker, this graph. So this is what we had before. And we wanted to find out what happens as x approaches 1. So this is 1. And as x approaches 1, f of x approaches 0.5, which was a half. I remember we're getting half as the answer for that one. Now the last one where I said the limit did not exist as x approached 1. What was it? It was x plus 1 over x squared minus 1. So let's change this to plus 1 and see what it is. What happened? Alright. As x approached 1. This is 1. Right here. Cancel the 1. Now let's go up and see what happened to the curve. The curve is getting closer and closer to the 1 line. But I can tell you it never reached the 1 line. Let's go down and see if this curve would ever cross this 1 line. This is 1, you know, the 1 line. And the curve is getting closer and closer to it. But will never reach it. No matter what. Alright? So, in that case, the limit of that function does not exist. Alright? So, that's it for now. I will see you in the next video.